Good day, grade 11 students. Welcome back to our general mathematics class. In my previous video lesson, I discussed about rational functions, equations, and inequalities, and representations of rational functions. Today, I will be tackling about chapter 2, lesson 3, solving rational equations and inequalities. So at the end of this lesson, we must be able to solve rational equations and inequalities as our objective. So let us now start our discussion of solving rational equations and inequalities. First is solving rational equations. So we need to follow several steps for us to solve rational equations. First is that we need to write the restriction or the restriction. Next is find the LCD, or what we call the least common multiple of the denominators. Then multiply both sides of the equation by the LCD, solve the equation, and lastly, check the solution. So let us have now our examples. So example number 1, 3 over x plus 1 half is equal to 5 over x. So as you can see here in our denominator, we can get here our restriction, because restriction means that these are values that should not be part of our solution. Okay? So in this case, we will equate x to 0, so x is equal to 0. So our restriction is that x should not be equal to 0. Okay? Next is to find the LCD, and our LCD on x2 and x is 2x. So multiply both sides of the equation by our LCD, which is 2x. So 2x divided by x is x times 3, so we have 6. 2x divided by 2 is x times 1, so we have x. And 2x divided by x is 2 times 5, we have 10. So we are multiplying both sides of our equation by the LCD for us to get rid of fractions. Okay? So we have now 6 plus x is equal to 10. Then after multiplying both sides by the LCD, we will now solve for our equation. So subtracting both sides of the equation by 6 will give us x is equal to 4. Okay? And let us now do the checking. So for us to check, we will just replace x by 4 on our given equation. 3 over x plus 1 half is equal to 5 over x. So if we replace it by 4, we have 3 fourths plus 1 half is equal to 5 fourths. Okay? So we have here 4 as the LCD. 4 divided by 4 is 1 times 3 is 3. 4 divided by 2 is 2 times 1 is 2. So we have 3 plus 2 on our numerator, okay, which is equal to 5. Then the denominator is 4, so we have 5 fourths now is equal to 5 fourths. Since after do the checking, it gives us a true statement, therefore we can say that x is really equal to 4. In other words, the solution of 3 over x plus 1 half is equal to 5x is 4. Okay? Another example, we have 2 over x minus 2 is equal to x over x minus 2 minus 4. So if we will equate x minus 2 on our denominator to 0, so x minus 2 is equal to 0, so x is equal to positive 2. Therefore, our restriction is that x should not be equal to positive 2, because if x will become positive 2, so we will have a meaningless or an undefined, okay, an undefined equation. Okay, so meaning 2 is not a part of our solution. Okay, so get the LCD. So we have here x minus 2, and we have here 1, since it is equal to 4 over 1. Okay, So our LCD is x minus 2. So x minus 2 divided by x minus 2, so we can cancel out this one. So we only have 2 is equal to x minus 2 divided by x minus 2, so we can cancel it out. So we have here equal to x. Then we have x minus 2 divided by 1 is x minus 2. So we will multiply it by negative 4. So it will give us 2 is equal to x minus, okay, we have here 4 times x is 4x, and 4 times negative 2 is negative 8. Okay, next, we need to remove this grouping symbol, okay, the parenthesis. So it will give us 2 is equal to x, distribute negative sign, we have negative 4x plus 8. Okay, then combine like terms. We can combine x and negative 4x will give us negative 3x. And then we can also subtract 8, okay, on both sides of the equation. And it will give us negative 6 is equal to negative 3x. Then dividing both sides of the equation by negative 3 will give us x is equal to 2. Okay? Since on our restriction x should not be equal to 2, and on our solution it gives us x is equal to 2 as the answer, so we cannot accept this value to be a part of our solution. In this case, you can say that there is no solution for this given rational equation. Okay? Since if you will do the checking, it will give you an undefined, okay, equation. Okay? So the given rational equation has no solution. Next, let's proceed to solving rational inequalities. So the question is that, is it valid to multiply both sides of an inequality by a variable? Why or why not? Ba? In our rational equation, to get rid of fractions, we multiply both sides of the equation by an LCD. And as you can see on our LCD, it contains variables. That in the previous case, we have variable x. Okay? So the question is that, is it valid? Can we also use that method in solving rational inequality? Can we multiply both sides of an inequality by a negative or by a variable rather? Okay? So let us recall. It is not valid to multiply both sides of an inequality by a variable. Recall that multiplying both sides of an inequality by a positive number retains the direction of the inequality. And multiplying both sides of an inequality by a negative number reverses the direction of the inequality. Same is also true if we are dividing both sides of an inequality by a positive number. So it will also retain the direction of the inequality. Okay? If you divide both sides of an inequality by a negative number, so the direction of the inequality also reverses. And since you do not know if the value of x or the given variable is a negative number or a positive, so you cannot determine whether you will retain or you will reverse the direction of the inequality. That's why it is not valid to multiply both sides of an inequality by a variable. Okay? So steps in solving rational inequalities. First step is to rewrite the inequality as a single fraction on one side of the inequality symbol and 0 on the other side. Make sure that both the numerator and denominator are expressed as completely factored. Next is to find the critical values for both numerator and denominator. These values will make the numerator and denominator equal to 0. Another step is to determine the intervals or regions on the number line determined by these critical values. Next, choose a test number in each interval or region. Inspect the signs of the numerator and denominator in these test numbers. Inspect the sign of the rational expression in each interval. Then choose the interval or region that satisfies the inequality. Okay? So we have 7 steps for solving rational inequalities. Let us have this example. 2x over x plus 1 is greater than or equal to 1. Okay. So your first goal is to make the left side of the inequality a single fraction and the right side 0. Okay? So, since we cannot multiply both sides by x plus 1, okay, so we need to subtract both sides of the inequality by 1. So, we have 2x over x plus 1 minus 1 is greater than or equal to 0. Okay? Then, we do not have yet a single fraction on our left side since we have two fractions, 2x over x plus 1, and we have 1 over 1. Okay? So get the LCD of x plus 1 and 1. We have x plus 1. Okay? And on our numerator, x plus 1 divided by x plus 1 is 1 times 2x. So we have here 2x. X plus 1 divided by, we have here 1 is x plus 1 times negative 1. Okay? So meaning, we can apply cross multiplication here. 2x times over 1 here, 2x times 1 is 2x. Then negative 1 times x, negative x. Negative 1 times positive 1, we have negative 1. And we will just copy the denominator x plus 1. Okay? Then, this is greater than or equal to 0. Then combine like terms. 2x minus x is x. Then we have minus 1 over x plus 1 is greater than or equal to 0. So our numerator x minus 1 is now completely factored. X plus 1 is also unfactorable. Okay? So since the left side of the equation is already single fraction and the numerator and denominators are unfactorable, okay, and the right side of the inequality is 0, so next step is to make table of signs. Okay? So we have here on the right side the table of signs. So get first the critical values. So on our numerator, if we equate it to 0, x minus 1 is equal to 0. So we have x is equal to 1. So meaning 1 is the critical value. On our denominator, x plus 1 is equal to 0. So x is equal to negative 1. So negative 1 is our critical value. Okay? So meaning we have critical values of 1 and negative 1. Okay? Or you can simply, by getting critical values, you can simply get the opposite sign of the second term. We have here negative 1. So opposite of negative 1, so we have positive 1. Okay? If we have positive 1, so the opposite sign of positive is negative, so we will have negative 1. Okay? What if we have here numerical coefficient? Okay, on our first term, we have, example, we have 5x plus 1 on the denominator. So if our denominator is 5x plus 1, so our critical value is that negative 1, okay, the opposite of positive 1 is negative 1 over 5. Okay, which is the leading coefficient of x. So if we have 5x plus 1, we have negative 1 over 5 as the critical value. Okay? So in this case, in our given, we have critical values of negative 1 and positive 1. So arranging that on our number line, okay, we have here negative 1, then positive 1. And on the left of negative 1, it goes up to negative infinity. And on the right of our positive 1, it goes up to positive infinity. So our table of signs is now divided into 3 regions. Okay? From negative infinity to negative 1, from negative 1 to positive 1, from positive 1 to positive infinity. Okay? Next, we have here x minus 1. So first row, we have x minus 1. Then we can get a test number or the test point in each region. So from negative infinity to negative 1, we can get negative 2. Okay, as the test point or the test value or the test number. So if x is negative 2, we have negative 2 minus 1 is negative 3. So the sign is negative. Okay? For this region, negative 1 to 1, we can get 0 as the test point. If x is 0, so we have 0 minus 1 is negative 1. So we have a negative sign. Okay? From 1 to positive infinity, we can get 2 as the test point. So 2 minus 1 is positive 1. So we have positive. Okay? Next, we have in the denominator x plus 1. So we will write x plus 1. Okay? Again, our test point is negative 2. So negative 2 plus 1 is negative 1. So we have here negative. Here, our test point is 0. So 0 plus 1. So we have positive 1. So we have positive. Okay? We have here test point of 2. 2 plus 1 is positive 3. So our sign is positive. And then, we will now divide these two. So we have x minus 1 over x plus 1. So negative over negative is positive. Negative divided by positive is negative. And positive divided by positive is positive. Okay? Now, our inequality says that x minus 1 over x plus 1 should be greater than or equal to 0. Meaning, the sign that satisfies our rational expression x minus 1 over x plus 1 are positive values. Okay? Positive values. And it is located on the region from negative infinity to negative 1, from 1 to positive infinity. Okay? Now, it says here, note the dotted line and open circle indicate that the critical value is not included as a solution. The solid line and shaded circle indicate that the critical value is included as solution. Okay? So here we have a broken line on our critical value of negative 1 and an open circle. It means negative 1 is not included as a solution. Why? Because negative 1 is the critical value of our denominator. And on our denominator, x should not be equal to negative 1 since if x negative 1, so we have negative 1 plus 1 is equal to 0. So it will make this inequality meaningless or undefined. That's why negative 1 cannot be, okay, the value of x. Okay? Now, how about positive 1? So it comes from our numerator x minus 1. So here, we can, our 1 here, the critical value 1, we use solid line and a dotted circle. Okay? Solid line and a shaded, solid line and a shaded circle. Okay, shaded circle. And indicates that the critical value is included as a solution. Why is it that 1 is included? Because if our numerator will become 0, so 1 minus 1 is 0, 0 divided by any value is equal to 0. So we will have, by checking, we will have 0 is greater than or equal to 0. And 0 is greater than or equal to 0 is true. Okay? Since it is true, so we can now say that 1 can be a part of our solution. Okay? So, in other words, just look at the inequality sign. If the inequality sign is greater than or equal or less than or equal, meaning it has an equal sign, so we can include the critical value as on our numerator as part of our solution set. Okay? But if we only have greater than or less than, example, 0 is greater than 0 or 0 is less than 0, so not included. Okay? That critical value cannot be included since we have a false statement. Okay? But in this case, 1 is included because 0 is greater than or equal to 0 is a true statement. Okay? So let us now get our solution set. So our solution set is that x, such that x is an element of all real numbers when x is less than negative 1 or x is greater than or equal to 1. So here we have x is less than negative 1, meaning negative 1 is not included. Okay? Or x is greater than or equal to 1. So 1 here is included up to positive infinity. Or, so this one is by means of set builder notation, and this one is by means of an interval notation. So interval notation, we can write negative infinity. Okay, so we have open parenthesis, negative infinity, comma, negative 1, open parenthesis. Why open parenthesis? Because open parenthesis denotes that negative 1 is not included. Okay, union with, since 1 is included, so you will use bracket. So the bracket denotes that the given value, which is 1, is included. Comma, then positive infinity, then close parenthesis. So we always use parenthesis for our infinity. Okay? So that is our answer on number 1. And we solve these rational inequalities by, again, using the test points. Okay? Another alternative is by locating zeros. Okay, by locating zeros. Okay, so same example with number 1. We have x minus 1 over x plus 1 is greater than or equal to 0. Okay, so we have already made this table of signs in our previous example. So we will just now locate zeros. So for x minus 1, where is 0 here? So 0 is located on positive 1. Since x minus 1 is equal to 0, x is equal to 1. So 0 is located on positive 1. So if we have here 0, it means that all of the numbers below 0 or to the left of 0 are negative numbers. That's why we have here negative, negative. Okay? And after 0, we have positive values. So that's why we have here positive. Okay? So you may apply this one. You need not to get test point or the test number or test value. Okay? Next, x plus 1. So where is 0 here? So look at the second term, positive 1, so negative 1. So negative 1, we have here a 0 on our negative 1. Okay? And to the left of 0, we have negative. To the right of 0, we have positive values. Okay? Then divide, negative divided by negative, positive, negative divided positive, negative, positive divided positive is positive. Okay? And again, we have this solution set. Okay? Another example. What if we have on the numerator x minus 1 times x minus 1 divided by negative x as the quantity of x plus 1, and it is less than 0. So get the critical values. So we have here x minus 1 is positive 1, positive 1 also here. So we have 1, okay, positive 1. Then we have here x, so x is equal to 0, so we have 0. Again, 1, 0. And this one, we have negative 1. Okay? So we have 1, 0, and negative 1. Arrange that on our number line. We have negative 1, 0, and 1. Negative infinity and positive infinity. Okay, so our table of signs now is divided into 4 regions or 4 areas. Okay? So x minus 1 times x minus 1 can be written as quantity x minus 1 squared. Okay? So we have on our numerator 1 as the critical value and the denominator 0 and negative 1. And our denominator 0 and negative 1, okay, cannot be the value of x. That's why 0 and negative 1 uses, 0 and negative 1 we use here a broken line and an open circle, meaning 0 and negative 1 are not part of our solution set. Okay? Next, on our numerator, 0 and negative 1 dito. 0 and negative 1. So, on our numerator, we have positive 1. Okay? And if our numerator, x is equal to positive 1, so we'll have 0 is less than 0, which is a false statement. That's why positive 1, okay, the critical value on our numerator is also not included as our solution set, because it will make our inequality statement false. Okay? Now, we have here x minus 1 squared. Okay? So, x minus 1, the critical value is on positive 1. So, we locate 0. It is located in positive 1. Values before 0, we have negative. And values after 0, we have positive. But take note that here we have squared. Okay? Instead of using x minus 1, then you will write again x minus 1. Another row. So we can have here x minus 1 squared. Okay? So meaning we will square its signs. So negative squared is positive. Negative squared, positive, positive. Positive squared is positive. So meaning here, on our first row, we will have all positive values. All positive signs. Okay? Because we will square the given, we will square the given signs. Okay? So we have now positive. Okay? Now, here we have negative x. So we equate x is equal to 0. So our 0 is on critical value of 0. Okay? So before 0 we have negative. After 0 we have positive. Okay? Now, we have here negative. Okay? Negative x. So we have negative. Okay, so meaning we will multiply our x by a negative. So meaning we will multiply each signs by negative. So negative will become positive, negative will become positive, positive will become negative, positive will become negative. So we have positive, positive, negative, negative. Okay? So after locating 0, observe, take note. If it has square, if it needs to be multiplied by negative. Okay? Then, we have x plus 1, negative 1 as the critical value. So, before 0, negative. After 0, positive. And on our last row, we have square of x minus 1 over negative x, quantity x plus 1. So, meaning we have here first row, okay, divided by the product of second and third row. So, positive divided by negative, we have negative. We have next positive divided by positive, we have positive. Then positive divided by the product is negative. So, positive divided by negative is negative. And positive divided by the product of this is negative. So, positive divided by negative is negative. And our inequality greater than 0. So, greater than 0 meaning positive. So, we have this solution set from negative 1 to 0, but negative 1 and 0 are not included. Okay? So, our answer now is the solution set using set builder notation, x such that x is an element of all real numbers, wherein x is greater than negative 1 but less than 0. Or, we have open parenthesis, negative 1, meaning negative 1 is not included, comma, 0, close parenthesis. 0 is also not included. Okay? Next. Solve the following rational inequalities. We have 3 over x minus 2 is less than 1 over x. Okay, so again, we have here, we need to transfer 1 over x to the left side. So we have 3 over x minus 2 minus 1 over x is less than 0. And get the LCD. So we have x times quantity x minus 2. Okay, then cross multiply. For our numerator, 3 times x is 3x. Negative 1 times quantity x minus 2. So negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. And combine like terms here, we have 3x minus x is 2x, then plus 2. Over, copy the denominator x as the quantity x minus 2, and copy less than 0. Okay? Then 2x plus 2 is still factorable. It has a common factor of 2. So we have 2 times the quantity of x plus 1 over x times the quantity of x minus 2. It's less than 0. So now, numerator is completely factored. Denominator is also completely factored. Okay? We have a single fraction, and on the right, we have 0. Okay? Next, get the critical values. So, critical values, saan ba mga may x dyan? So, here on the numerator, we have x plus 1. So, we have negative 1 as the critical value, negative 1. Here, we have 0. So, negative 1, 0, and positive 2. So, negative 1, 0, and positive 2. And we have negative infinity and positive infinity. Okay? So, our numerator, 2 times the quantity x plus 1. So, 2 times the quantity of x plus 1. Okay? So, if we locate 0, so 0 is a negative 1. Okay? So, before 0, negative. After 0, positive. Then, we have x. Okay? So, x, 0 is located on the critical value, which is 0. So, before 0, we have negative. After 0, we have positive. Next, we have x minus 2. So, the critical value is on positive 2. So, before 0, we have negative. And after 0, we have positive. Next, the product of quantity of x and x minus 2. So, negative divided by negative is positive. Negative divided by negative is positive. Positive divided by negative is negative. And positive divided by positive is positive. Okay? Then, we need now to divide the first row, 2 times the quantity x plus 1, and the fourth row, which is x times the quantity of x minus 2. Okay? Since that is our inequality on the left side of our inequality, we have 2 quantity x plus 1 over x times quantity of x minus 2. So, color red. So, we will divide. So, first row and fourth row. So, negative divided by positive, we have negative. Positive divided by positive, we have positive. Positive divided by negative is negative. And positive divided by positive is positive. Since our inequality states that less than 0, so we can say that negative. So, we have here negative on the area or region from negative infinity to negative 1, but negative 1 is not included. Then, 0 to 2, wherein 0 and 2 are also not included. Okay? So, 0 and 2 in the denominator, they are not included. On the numerator, negative 1, it is also not included because we only have here less than 0. 0 is less than 0 is a false statement. Therefore, we have here negative 1 is not included. So, let us now write the solution set. So, x such that x is an element of all real numbers wherein x is less than negative 1 or x is greater than 0 but less than 2 for a set builder notation. And for our interval notation, we can write it as open parenthesis, negative infinity, minus 1, union with 0, okay, open parenthesis 0, comma 2, close parenthesis. Okay? So, let me end my discussion with this Bible verse from Matthew chapter 11 verse 28. Come to me, all who labor and are heavy laden, and I will give you rest. So, thank you so much for watching. Goodbye, grade 11 students. Keep safe and God bless. Jesus loves you.